So last time we talked about the method of partial fractions by splitting a denominator into its two parts. Here we've got a similar problem. We've got three parts though underneath. Underneath we've got a cubic. How do I know we've got a cubic underneath? Well, to multiply out those brackets, why am I going to end up with a cubic? X times x times x. At some point I'm going to end up multiplying those three x's together, so I'm going to have a cubic. So is this fraction top heavy? No, it's not. Okay? So we don't have to worry about polynomial division, which is something that we started thinking about last week and we'll talk about a bit more today. We haven't got to worry about this being a top heavy fraction. So in theory we can do this using the method of partial fractions. So the first thing we do is to think about this fraction over x plus 1, x minus 2, x plus 3 as equivalent to some fraction over the first factor, x plus 1, plus another fraction over the second factor, x minus 2, plus something over x plus 3. So I split my fraction into the 3, which is a similar idea to what we did last week. And it's all about finding out what goes on top. So we, for now, just call them A and B and C. So now the overall idea is to focus on this right hand side, recombine this fraction if you like, so that we get this common denominator, which is this, and then equate numerators. So it's exactly the same idea. Now what we do is this cross multiply idea. If you think about it, this fraction here, I want it to be something over this whole denominator, x plus 1, x minus 2, x plus 3. I want that to become something over that. So I've got the A, but if we think about this, I've got the x plus 1, I just want these other two, so I multiply top and bottom by the other two, effectively, and then carry on for the other two. So this becomes A times x minus 2, x plus 3, and if you look at it, I could cancel these out, and I'm left with A over x plus 1, which is this. So that is that fraction, but I've just turned it into one that's got the denominator that's on the same as on the left hand side. Now I do the same for the other two fractions. So write down what the other two fractions will be. So hopefully you get something like this. I just shifted it a bit, focusing on the right hand side only. Here's our first fraction. This isn't a bad idea. You know, the denominator is going to be the same every time, so just replace that by d for the denominator. I'm really only interested in the numerator. So effectively, I hope you can see the pattern, and it actually doesn't matter how many terms I've got. What I end up doing is multiplying by the rest of the factors that are underneath. So the second one, that's got the x minus 2, so I just need the other two, the x plus 1 and the x plus 3, and the same for the other one. Can you remember what we do now? We equate numerators. I'd like you to state that. And so, what is the numerator on the left-hand side? 2x squared minus 9x minus 35 is equivalent to a x minus 2, x plus 3, plus b, x plus 1, x plus 3, plus c, x plus 1, x minus 2. Next step is to try and eliminate two of the unknowns. Look at these factors here. If x equals 2, 2 minus 2 is nothing. If x equals 2, that disappears, which means this whole term is gone, doesn't it? Also, if x equals 2, that term disappears. So I'm only left with this one. So I can pick values for x, and I would do this 3 times for 3 different constants, a, b and c, and work out what x is. So I'm going to let x equal 2. That means I've got to substitute in 2 here, so I can work out what the left-hand side is, and hopefully then work out what b is. So I'll pause this here and let you see if you can finish that problem off. Find out what the values for a, b and c are. So you should end up with these values. If x equals 2, b equals minus 3. If x is minus 1, a equals plus 4. And if x is minus 3, c equals plus 1. If you don't get those, just go back and just check. So now we've got our values for a, b and c, we can plug them back into the original function, which is this one here. So with our values of a, b and c, we can put them back in here. So we can replace this original function, remember that we're supposed to integrate this, we can replace that with that. And that's just 3 separate integrals that we can then use that standard integral that we mentioned earlier to write down the answer. So now we've got that file, write down the answer to this problem. So you should end up with that. And of course, if this was a definite integral, say between 1 and 2, we would then put our square bracket round all of this lot, ignoring the c, and put our values of 1 and 2 in to work out the answer.